Whoa, Peter. Internet space sure is big.
Yeah, check out all the network planets. There's a Class A network right there.
And there's a Class C over there. Whoa! What's happening?
Something's going on with that Class B network planet down there. Uh-oh, hold on, Pixie. Looks like we're going down. Peter, back in! Phew, that was a close call. I wonder
Peter? What are these things?
Hello, Pixie, Peter. Looks like you two have landed on a network planet.
Hey, what's up, Terry? Peter, this is my friend Terry B. Router. He's the smartest guy I know. Terry, can you help us figure out what's going on here?
Well, you've landed on Planetary Pharmaceutical Company's network. It seems to be a bit of a mess.
Yeah, what are these things?
These are bits, Peter. Don't worry, they're very friendly creatures. Bits are the smallest unit of data in a computer. A bit has a single binary value, either 0 or 1. Bits are often in groups of 8, known as octets. Network administrators transform octets of binary numbers into decimal numbers so they are easier to remember and work with. For example, this octet, in binary, is equivalent to 128 plus 8 plus 2 plus 1, which is 139. 4 octets make up an IP address, which is used to identify devices on a network. For example, a computer, printer, server. All of these have individual IP addresses that are in the form of 4 octets. These can easily be translated into decimal form as well.
Well, that's all good to know, but what's wrong with this planet?
Some kind of pressure must be building up under the surface.
That's absolutely right, Pixie. The network administrator neglected to subnet the network, so what you see is a buildup of data traffic. All these IP addresses need to be organized into logical subnetworks in order to better segment the traffic on Planetary Pharmaceuticals' network. Peter, Pixie, are you up to the task?
Let's do it!
The first thing you must do is explore the network and find out how many subnetworks you'll need. Good luck!
Look down there. There's the accounting department and manufacturing and engineering.
But wait, looks like this network planet has another continent that has 2 more countries. Human resources and sales. Well, it looks like there are 5 major administrative branches within Planetary Pharmaceutical Company, so we'll need 5 subnetworks.
I don't think so, Peter. Did you see how separated the 2 continents were? Why don't we keep each office separated by linking them each to their own router? That means that the 2 routers will need to be on their own subnetwork so that they can talk to each other. That makes 6 subnetworks altogether.
Great assessment, Pixie.
That's what I was gonna say next.
Don't be scared. This is our buddy, the Masker. As you know, an IP address has 2 parts. A series of bits that tells you what network the device belongs to, and a series of bits that is specific to the device, also known as the host ID. The default network mask for a Class B network has 16 ones and 16 zeros. 255.255.0.0. If you take any IP address and apply the AND logic operation to it and the network mask, you'll get the network address. See?
Seems like all these IP addresses have the same network address.
Of course they do, Peter. We're on Planetary Pharmaceutical Company's network. All these addresses are part of the same network. We just need to find a logical way to designate each IP address to a branch of the company.
That's right, and the Masker will help you do that. Can you imagine how?
Well, if we need 6 subnets, can we somehow use the network mask to create a subnetwork mask?
I think you're onto something, Peter. The mask has got to change so that it can distinguish 6 separate subnets rather than just one network.
You're both right on track. You must borrow bits from the host address portion of the mask and turn them into ones to get the subnet mask. The portion of the IP address that corresponds to the bits you borrowed is considered to be the subnet address, and depending on how many bits you borrow, you can create a different number of subnets. For example, if you borrow 2 bits, how many different combinations of ones and zeros can you make with those 2 bits?
Well, you have 00, 01, 10, and 11. 4. Well, that's easy.
That's right. And if you borrowed 3 bits?
8, of course, and 16 if you borrow 4 bits.
How'd you do that so fast?
That's easy. To find out how many combinations of ones and zeros you can have, just take 2 to the nth power, where n is the number of bits you have.
Oh, I get it.
So if you need 6 subnetworks, what is the minimum number of bits you can borrow?
Well, 2 bits only gives you 4 combinations, and that's not enough.
But 3 gives you 8, which is greater than 6. So the answer is
3! And if we wanted 7 or 8, we would still only need to borrow 3 bits, right?
Nuh-uh. You can't have all ones because that's the broadcast address. And you can't have all zeros because that's the subnet address. So that gets rid of 2 possible subnet addresses. You'd have to use 4 bits for 7 or 8 subnetworks.
That's right, Pixie.
But doesn't that leave fewer possible host addresses?
Yes, it does. If you borrow 3 bits, there are only 13 left to create host addresses from. But as long as there are enough host addresses for all devices on the subnetwork, then you're fine. Peter, how many possible host addresses do you think 13 bits can create?
13 bits. So I think the answer is 2 to the 13th power, which is something huge.
8,192, to be exact.
Now that you know what a subnet mask is, it'll be easy to learn about IP address notation. You remember how to turn this address into decimal form, right?
Yup. That bit has a value of 128, then 32, 8, and 4. That makes 172. And the other octets are 16, 196, and 24.
Great job, Pixie. Now, there's something called slash notation. It is simply the number of ones used in the subnet mask. What do you think it is in this case?
The network part of the address has 16 bits, and we borrowed 3 bits for the subnet. So 16 plus 3 equals 19.
Exactly. This is a common way to write out an IP address, and an easy way to tell how many bits were borrowed to create subnet addresses.
Well, now that we understand all this, we've got to figure out where all these little IP addresses should go.
Right. Let's get back to work. First, you must assign address ranges for each of the subnetworks.
How do we do that?
First, think of all the combinations you can make using the 3 borrowed subnet bits.
Well, there's 000, 001, 010, 011.
Wait, you can't use all zeros. Remember, Peter?
Oops. That's right.
You can't use all ones either, because that combination is reserved as a broadcast address. Any data sent to that address is broadcast to all devices on that network.
Okay, so that leaves 100, 101, and 110.
I still don't get it, though. How do we know which IP addresses go where?
We've already seen that Planetary Pharmaceutical Company has been given 172.16.0.0 as its network address. Let's look at the binary version of that number. Starting at the 17th bit, the next 3 bits will be used to define the subnet. So let's start with 001. Pixie, what is the smallest number that you can create with the remaining 13 host address bits?
Well, you can't have them all be 0. So I suppose the smallest number would have only the far right bit be a 1.
Right. And Peter, what's the largest number you can make with the 13 host address bits?
All ones!
Are you sure?
No, sorry. I mean all ones with the last bit being a 0, since all ones would make the broadcast address.
Very good. So there you have it. You've defined the host ranges for one of the subnets. Now, all you have to do is turn these addresses into decimal, so they aren't quite as clumsy and hard to read.
Awesome! Let me try. So we'll use the next combination of 3 bits, 010, as the subnet address, and use the smallest combination of the remaining 13 host address bits and the largest, change that into decimal form, and voila! There's the next subnetwork range.
Oh yeah, I almost forgot about those 2 IP addresses that belong to the router interface subnet. That's our last subnet. Looks like we're all done.
Yes, you are. You both did a great job. And on top of it, the Masker fixed your rocket as a thank you for subnetting Planetary Pharmaceuticals Network.
Thanks, Masker.
Hey, Harold, great job organizing and subnetting our network.
Whew, that was a lot of work. Glad that's over with.
Whoa! Uh-oh, here we go again!